Okay, so in this video, we will talk about the arithmetic sequence. So, an arithmetic sequence is given by the form a sub n is equal to a sub 1 plus n minus 1 times d. A sub n here denotes the nth term, a sub 1 denotes the first term, n here denotes the number of the term in the sequence, and d here denotes the common difference. So for example, if I have here the sequence 5, 10, 15, 20, and 25. So this is an example. Our a sub 1 is the 5, our a sub 2 is 10, our a sub 3 is 15, our a sub 4 is 20, and our a sub 5 is 25. The following terms or the preceding terms can be denoted by a sub n. So for example, we are tasked to find the 20th term of this sequence. So the 20th term will be denoted by a sub 20. Before we can do that, we first have to get the common difference. How do we get the common difference? So you just have to follow a sub 2 minus a sub 1, a sub 3 minus a sub 2, a sub 4 minus a sub 3, and so on. So let us substitute. 10 minus 5, that's 5. We have our a sub 3, that's 15. A sub 2, that's 10. So we have 15 minus 10, that is 5 also. A sub 4, that is 20. Minus a sub 3, that is 15. So 20 minus 15, that is also 5. Thus, we do have a common difference which is equal to 5. Take note that a sequence can only be considered as an arithmetic sequence if they do have a common difference. So now that we already have our common difference, we can now find for the 20th term. Let's go and look for the 20th term by using this formula. So our a sub n will be a sub 20 since again, we are looking for the 20th term. Our a sub 1 in the sequence is equal to 5. So we will substitute 5 to a sub 1 plus our n, that will be 20. Whatever the value of your n in the left side will also be the value of your n to the right side. So we have 20 minus 1 times the common difference, which is equal to 5. This will give us 5 plus 20 minus 1, that is 19 times 5. So we have here 5 plus 19 times 5. Let's use a calculator. We have 19 times 5, that's equal to 95. 95 plus 5, that is 100. This means that the 20th term of our sequence is equal to 100. Same when you want to solve that manually without using the formula, we will still come up with the same answer. Let's try to have it. So we have 5, 10, 15, 20, 25. Now, we will be adding 5 to every term so that we will come up to the 20th term. 25 plus 5, that is 30, plus 5, that's 35, plus 5, that is 40, plus 5, that's 45. We have 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So we just simply added 5 to each term because our common difference is 5. Now let's count if 100 here is the 20th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So you see, whether you will be using the formula or whether you will manually compute that one by adding the difference or the common difference, you will still get the same answer. Okay, now let us try to have another problem. Okay, let's clear this one. Let's have another problem. I forgot. Let me write it again. So arithmetic sequence. I write it here. Okay, suppose that our a sub 1 is equal to 5. Our a sub n is equal to 395 and our common difference is equal to 5. What is the value of your n? So find n. By using the same formula for the arithmetic sequence, we can find the answer to that. Again, the general form for arithmetic sequence is a sub n that's equal to a sub 1 plus n minus 1 times d. So a sub n in here is equal to 395. So let's substitute that one. 395 equals our a sub 1, that is 5, plus our n, that is still unknown, minus 1 times the common difference, which is 5. So we have 395 is equal to 5 plus, this time we do have a parenthesis. So we will be distributing each term inside that one to outside. So n times 5, that's 5n. Negative 1 times 5, that's negative 5. Now we have 395 equals, in this case we have two constants. So we will combine the constant, this one, 5, and then we have negative 5 plus 5n. Now let's simplify. Still copy 395 equals 5 minus 5, that's 0. So we are left with 5n. Again, our aim in here is to get the value of n. So we need to eradicate the constant or the numerical coefficient 5 in here. That can be done by dividing 5 to both sides. So we are left in here with n, and on the other side we have 395 divided by 5. The answer is 79. So this means that the value of our n here is equal to 79, and a sub 79, or the 79th term in the sequence, is equal to 395. Now, if we do have a method on how to find the missing terms in a sequence, we also have a method on how to get the formula on a particular sequence. So suppose I have here the sequence 15, 19, 23, 27. Okay, how am I going to get the formula of this sequence? That is by using by this form. A sub n, that's a sub n, not a times n. Let me do it again. A sub n is equal to d times n plus c. C here is just equal to a sub 1 minus d. So we just simply substituted a sub 1 minus d to c and copy the rest in the formula. We have d times n. Now let's find out. Copy a sub n, that's equal to the common difference d. So let's find out what the common difference is. We have 19 minus 15, that's 4. 23 minus 19, that's also 4. 27 minus 23, that's also 4. So we have here 4n plus our a sub 1, that is 15, minus our common difference d, which is equal to 4. So we have here a sub n, that's equal to 4n plus 14 minus 15 minus 4, that is 11. This means that the formula for this particular sequence is just equal to a sub n equals 4 times n plus 11. Now let us identify our sequence, or the terms in our sequence. We have a sub 1, a sub 2, a sub 3, and a sub 4. Let's try to look for a sub 5 by using this formula. So a sub 5 is equal to 4 times 5, since our n is equal to 5, plus 11. So this gives us 4 times 5, that is 20, plus 11, that is 31. The fifth term is equal to 31. Same thing, if you will be adding 4 to 27, you will also get the answer as 31. So that's how you get the formula for a particular arithmetic sequence. Now let's talk about the arithmetic series. Let me clear this one first. Let's talk about the arithmetic series. When we say arithmetic series, it is the sum of the terms in an arithmetic sequence. So let's have an example. If we have here 2, 4, 6, 8, and 10. This is an example of arithmetic sequence because they do have a common difference, which is 2. 4 minus 2, that's 2. 6 minus 4, that's 2. 8 minus 6, that's 2, and so on. To get the sum of all these terms, we can use the formula. We have S sub n, that's equal to n over 2, or n divided by 2, times a sub 1 plus a sub n. So, for example, we are tasked to look for the sum of the 5 terms. So, we will have here s sub 5. Our n is equal to 5, so we have 5 over 2 times a sub 1. In this sequence, the first term is 2. We have here 2 plus our a sub n. Let's say we will be using a sub 5 since we are looking for the fifth, the sum of the first 5 terms man. Now we have s sub 5, that's equal to 5 divided by 2, that is 2.5 times 2, plus our a sub 5, that is 10. This gives us 2.5 times 12. Now let's multiply 2.5 times 12. That is equal to 30. This means that the sum of the first 5 terms in this sequence is just equal to 30. Or we can do that by adding these numbers, 1, 2, 3, 4, 5, since these are the first 5 terms of our sequence. So let's try to add. We have 2 plus 4 plus 6 plus 8 plus 10. We will still come up with the same answer, which is equal to 30. So that is your choice whether you use the formula or you manually solve without the formula. That would be all for the arithmetic sequence and series. If you do have questions or suggestions, comment it down. Thank you.